Hi guys, so today we'll be taking a question on wave. Another question, we're taking another question, solving another question on wave. Now this is a confirmed standard wave question. This is a serious wave question. And these are the kind of questions you will be expecting in your various exam, whether CBT or German, anyone. This kind of question you're going to expect. And this question, you should not even take more than 1 minute when you're writing your exams. Yes, it should not take more than 1 minute. Forget that like it's looking very bulky like this. I'm going to break it step by step so you're going to understand and tricks you're going to use to save time for you. But before I proceed, please like my videos. It will not take you just 1 second. Just click on the like button, subscribe, so that we'll be getting more videos of questions I'll be sending you. You'll be getting more videos. Subscribe and share my videos. So in this question, the question says a uniform string of length 200 centimeter. A uniform string of length 200 centimeter and mass 6 gram is kept under a tension of 70 Newton. Is kept under a tension of 70 Newton in the horizontal direction. How long will it take a transverse force to cross the whole length of the string? Question A, I go again. It said a uniform string of a length 200 centimeter and mass of 6 gram is kept under a tension of 70 Newton in the horizontal direction. How long will it take a transverse force to cross the whole length of the string? Now the B partner says if the string is replaced by another one of the same material but of double thickness and length 70 centimeter, how should the tension be adjusted so that the wave will cross the entire length within the same interval as in A? So you can see the question very clearly. Let me just go to the B again, the B part. The B said if the string is replaced by another one of the same material but of double thickness and length 70 centimeter, how should the tension be adjusted so that the wave will cross the entire length within the same time interval as in A? This is so sorry. I know my handwriting is not that good, but just manage. Now we proceed. In this question, we are solving A part first. We are given our length. Giving our length. The A part. What do we give us our length? They said our length is 200 centimeter. 200 centimeter. If you convert this to meter, that is going to be 2 meter. We are given our mass. He told us our mass is actually 6 gram. Convert this to kilogram. Here is going to be 0.006 kg. How do you convert gram to kilogram? You simply divide this by 1000. How do you convert centimeter to meter? You simply divide centimeter, divide it by 100. So that's how we got it. Now we were given our tension in A part, in the A. Our tension, which is T, is equals to 70 Newton. 70 Newton. Now, we are asked to find the time there, the time interval. You are finding the time interval. How long will it take? You are actually finding the time. You are actually finding the time. But to get that, you first of all you are going to find our mass per unit length. Yes, first find our mass per unit length. We are going to find our mass. We're also going to find our velocity. Because you know that if you are finding time is actually distance divided by velocity. So first of all, find our mass per unit length. So our mass per unit length which is this is equals to m all over L. You are given our mass. What is our mass? Our mass is 0.06 kg divided by our length. What is our length? 2. That means our mass per unit length will be equals to 0.002 kg per meter. Exactly. Now, what does it mean? This thing means that every meter of the strings weighs 0.002 kg per meter. That's what it means. Yes, that's what it means. Sorry? No, this calculation, no. If you divide this by this, you're going to get 0.03. Yeah, not 0.02, 0.03. Sorry about the mistake. I just checked it now. It should be 0.03. Yeah, 0.03. So it means that every meter of the strings, like each of the meter of the string will weigh 0.03 kg per meter. Now let's find our wave speed. Remember, our wave speed is actually equals to your t divided by u. This is mass per unit length. So our v, what is our tension? We are given our tension. Our tension is actually 70 Newton divided by, what is our mass per unit length? 0.03 all squared. Exactly, all squared. And what will this give us? This give us 233. Yeah, am I right? Yes, 2333. Yeah, this is what it's going to give us. If you divide this by this, only 70 divided by 0.003, you're going to have this. Then if you square this, that means your v will be 153. This is 153 meter per second. So you have gotten our velocity now. And what does this thing mean? It means that the pulse moves at 153 meter per second, 153 meter per second. That's what is moving. Now, let's find the time, because it's the time that told us we should find. We're actually finding the time, but for we to get the time, we have to find first our mass per unit length, and then find which we use to find our velocity. Remember that our velocity, there is speed, v, is equals to distance, which is d, divided by time. Exactly. You should all know this. It's always taught in JS1, or you call just JS1, yeah. So if you cross and multiply this, you're going to have your time t will be equals to your d all over v. That means your t is going to come here, v is going to come here. You are doing cross and multiply. And we are giving our distance. What do you have our distance? It told us our distance is 2. What do you have our velocity? Our velocity is 153 meter per second. 153 meter per second. Exactly. So if you divide these two by 153, the time should be 0.013 seconds. Yeah, 0.013 seconds. So that's actually the time. That's actually the time it will take to cross the strings. I'm just writing for you. Say the pulse crosses the string in 0.013 seconds exactly. So this is the answer to the A part. Now let's do the B part now. Now, in the B parts, we have a new string now. In the B part, we have a new string. B. Now, in the new string, this is the new string. Now, in the B part, they said is of the same material. If you read the question again, they said of the same material. Let me highlight the point. They say of the same material. They say double thickness, and they say now the length is now 70 centimeters. It's no longer 200. It's no longer 200 here now, but now it's now 70 centimeters, and of the same time. So the new string say the same material, double thickness. That is the question of double thickness, length. You have a new length right now. The new length is actually 70 centimeters, which is actually 0.7 meter if you cover this to meter. And we want, what do we want there? We want the pulse. You said you want the pulse to cross it in the same time. And what was the time there? What do we got? We got 0.0013 seconds here. Exactly. Look at it here in the question B. You say that within the same time interval. The same interval as in A. So in the second question, they say the new string now, the same material, double thickness and length. The length is now 70 centimeters, no longer 200. And we want the pulse to cross it in the same time. Now, what do you notice now? If the thickness is double, the strings will become what? The strings will become heavy. Yes. If thickness doubles, therefore the the strings will now become heavy. That means your U will be multiplied by 2. Yes, your mass per unit length will be multiplied by 2. That's what it means. If the thickness doubles, that means this thing will be multiplied by 2. And what do we have? What are we going to have? That means our U will be In the initial question, we have what we got was our mass per unit length. We have what we got 0.003 kg per meter. So you're going to be 2 times 0.003. So this is going to give you 0.006 kg. This is actually a standard question, and this kind of question you're going to see in your exams. You just have to pay attention. And one thing about physics is interpretation, able to interpret. If you're not able to interpret the question, I bet you, even though you know the formulas, you still not be able to get the final answer. So that's why I always take time. Even tell my students, before you answer any question, don't just plug in your formula. Understand the question. Like this one, it said the thickness doubles. If someone did not look at this now, you just go ahead and multiply it like that without knowing that this thing is going to double, the thickness doubles. So now, let's find the required speed. Because now the thickness has doubled, let's find the required speed. Required speed v, which is equals to the same distance divided by time. What distance did they give us now? The distance now they give us is 0.7 meters. 0.7 meters. They say with the same time, y is 0.013. 0.013. That means your speed is going to be 53.85 meters per second exactly. So you've gotten our speed now. Now, the new wave must have, what does this speed means? The new wave now must have 53.8 meters per second. That's what it means. Like the new wave is going to have 53.8 meters per second if the length is 0.7 meters. If the length is 0.7 meters. Now, they actually telling us to find the new tension. Is the tension we are actually finding? The new tension, the new tension. Listen very attentively, which is T. So this is what we are using. We are using our V is equals to this is what we are using. Now, why do we solve all this? We are actually finding, they told us to find our tension. But we cannot find our tension without knowing, we don't know our release velocity yet, we don't know our mass per unit length. So that's why I first of all find our mass times unit length, and then came and find our velocity. So now we are just going to plug in all this into this formula. But before we do it, we have to make our tension T the subject of the formula there. You first of all square the both sides here. So your V squared, you're squaring the both sides equals to your T all over U. This is mass per unit length, all squared. You're squaring the both sides. This square, you cancel the square roots. You're left with V squared is equals to T all over mass per unit length. You're going to cross and multiply. If you cross and multiply, this is going to multiply this is over 1. And this will multiply this. That means you have your T is equals to your V squared times your mass per unit length. Therefore, attention, what do we have our velocity here? Of giving a velocity. Our speed is this speed, not velocity. Our speed is actually 53.85 meters per second, all squared here. Then what do we have as a mass per unit length? We got 0.006 times 0.006 exactly. This is times. So when you multiply this, you should have, first of all, this will give you 2900 times 0.006. Multiply these two together, you have 17.4 Newton. Yeah, 17.4 Newton. And this is our final answer. Now, let me just give you something to know about this question B now. So the tension is reduced from 70 to 17.4. Notice, in question A, they told us that the tension was 70. But when we solve in question B now, the B part, the tension is now 17.4. 17.4. Why is it like that? Why is it like that? Let me just write something down for you guys. So tension, it should be tension tension is reduced from 70 Newton to 17.4 Newton. 17.4. Why? Because the strings becomes heavier. That's what we want to write. The first thing, the string becomes heavier. That is, your mass per unit length is doubled. And heavy string slows down wave. Heavy string slow waves down. Yeah. You can see you was told us at first that our strings was double. So that's why the strings becomes heavier. Because our mass per unit length is heavier. And heavier strings slow waves down. Heavier strings slow wave down. Now notice that now you know that the distance before in the A part was 200 centimeter. But in the second one we are giving 0.7 meter instead. What does it mean? It means that we don't need a very high speed anymore. And if you don't need it, to get this 53.85 meter per second, we must reduce the tension. So that's actually a solution to this kind of question. When you're solving question, you don't have to go all this. Just if you know, just know your parameters and know try to interpret the question. Try to interpret it very well. You don't need to write all this. I'm just giving you some reference so that you can actually understand the question in details. So that is actually the solution to the question. Thank you very much for watching. Have a wonderful day. Please subscribe. Click on the subscribe button, comment and share, and also like my videos. Have a nice day.